Here's the shocking part first. In 2023, a controlled study gave professional developers access to an AI coding assistant and measured their output. Productivity went up, sometimes dramatically. But when researchers looked closer at who benefited most, the results didn't match the story most people assumed. The programmers who gained the least from AI assistants weren't the weakest developers. They were often the most average ones, the ones executing familiar patterns competently, but without deep understanding. Meanwhile, the developers who gained the most and became measurably harder to replace were the ones who were already excellent before AI ever entered the picture. That's the opposite of what most predictions about AI and programming assumed would happen, and today we're breaking down exactly why. Let's start with the reveal. AI models writing code are extraordinary at one specific thing: pattern completion. Give a large language model a prompt describing a common problem, and it can generate a plausible, often correct solution almost instantly, because it's seen millions of similar patterns during training. What it fundamentally cannot do, at least not yet, is something researchers call novel problem construction, generating a genuinely new solution to a problem that doesn't closely resemble anything in its training data. That distinction sounds subtle. It isn't. It's the entire ballgame. To understand why, go back to something we've talked about before: expertise compression. The way a grandmaster sees a handful of patterns instead of 32 individual chess pieces. The way an experienced programmer recognizes a recursive function, missing a base case instantly, instead of reading line by line. Here's the part that changes everything about how we should think about AI and coding. Large language models are, in a very real sense, running an extreme version of exactly that same compression trick, except at a scale no human brain could ever match. They've compressed an almost unimaginable number of code patterns from an almost unimaginable number of sources into something that can retrieve and remix them instantly. Think of it like the difference between a musician who has memorized 10,000 songs and can play convincing covers of nearly anything, versus a composer who can write something that has never existed before. The cover musician's skill is genuinely impressive and genuinely useful. It is not the same skill as composition, and no amount of expanding the cover musician's song library turns them into a composer. It just makes their covers better and more varied. This is exactly where great programmers hold an advantage that pure pattern matching, no matter how sophisticated, cannot replicate. A great programmer's real value was never memorizing syntax. It was decomposition, the ability to look at a problem nobody has cleanly solved before and break it into a structure that can actually be built. AI is extraordinarily good at filling in a structure once a human has defined it. It struggles significantly with defining the structure itself when the problem doesn't map cleanly onto anything it's seen. Here's where the research gets specific. A widely discussed 2023 study from MIT and Princeton examined GitHub Copilot's actual impact across thousands of developers. Productivity gains were real, but they weren't uniform. Developers working on well-established, pattern-heavy tasks saw the biggest speed increases. Developers working on genuinely novel architecture decisions, unusual edge cases, or systems with no clean precedent saw far smaller gains. And in some documented cases, AI suggestions actively introduced subtle bugs that only an experienced reviewer caught. The tool wasn't failing randomly. It was failing predictably, exactly at the boundary where pattern completion runs out and genuine problem construction has to begin. This connects to something we discussed with vibe coding, the difference between construction and evaluation, the multiple demand network doing real work versus passively approving output. But there's a deeper layer specific to why expertise matters more, not less, in an AI-assisted world. Someone has to catch the AI when it's confidently wrong, and confident wrongness turns out to be one of the most well-documented failure modes in current AI coding tools. Researchers call this the fluency trap. AI-generated code often looks clean, well-formatted, and confident, all surface signals humans instinctively associate with correctness. But fluency and correctness are not the same thing, and a model can generate beautifully formatted code that's subtly, catastrophically wrong. Catching that requires exactly the deep pattern library we talked about with expert programmers, the kind built only through years of debugging real, messy, non-textbook problems. This is the myth-busting twist, because the popular narrative got the danger backward. The assumption was that AI threatens programmers by being too capable. The research suggests the actual danger runs the other direction. AI is dangerous specifically because it's convincing without always being correct, and the people most vulnerable to that danger are the ones without the expertise to catch it. A junior developer relying heavily on AI-generated code they don't fully understand is building on a foundation they can't personally verify. A senior developer using the same tool is using it the way an experienced pilot uses autopilot, a powerful accelerant, constantly cross-checked against real understanding. There's a useful way to picture the actual relationship forming between AI and skilled programmers. Think of AI less like a replacement worker and more like an extremely well-read, but occasionally unreliable junior collaborator, someone who has read every textbook ever written, but has never actually shipped a product, never debugged a system at 2 a.m., never dealt with a genuinely novel edge case nobody anticipated. That collaborator is enormously useful for drafting, for exploring options quickly, for handling boilerplate. It is not yet someone you'd trust to make the architecture decision that determines whether the whole system holds up under real-world conditions nobody wrote a training example for. Here's the honest complication, because it would be dishonest to pretend this dynamic is permanent or that no programmers are at risk. The research is fairly consistent on one uncomfortable point. Programmers whose entire value was executing well-known patterns competently, the coding equivalent of the 300 to 350 millisecond processor bracket we talked about with reaction time, careful, methodical, but not pushing into genuinely novel territory, are the ones facing the most real pressure. AI compresses exactly that category of work faster and cheaper than a human can. That's not a comfortable thing to say, but pretending otherwise would be exactly the kind of dishonesty this channel tries to avoid. What it means is the bar for what counts as irreplaceable expertise is rising, not disappearing. The skill that used to differentiate a good programmer from an average one, writing correct working code, is becoming table stakes, something AI increasingly handles at scale. The skill that differentiates a great programmer from a good one, decomposing genuinely novel problems, catching confidently wrong AI output, making architecture decisions with no clean precedent, understanding a system deeply enough to know when a plausible-looking answer is actually a landmine. That skill is becoming more valuable, not less, precisely because it's the one thing pattern compression at any scale cannot substitute for. There's a physical dimension worth mentioning too, tying back to neuroplasticity. The programmers most at risk aren't necessarily the ones using AI the most. They're the ones using it passively, the way we discussed with vibe coding, never exercising the multiple demand network deeply enough to build the pattern library that lets them catch the model's mistakes. The programmers becoming more valuable are the ones using AI as an accelerant for the parts of the job that were never where their real skill lived, freeing up more time and attention for the parts that were. So here's the truth all of this points to. AI isn't replacing great programmers. It's replacing a specific, narrower category of programming, the part that was always closer to pattern retrieval than genuine problem solving. That category was never where expertise actually lived, even though for a long time it was mistaken for expertise, because it was the visible, measurable part of the job. What's left standing and becoming more valuable by the year is the part that was always the hardest to teach and the hardest to fake, the ability to see a problem nobody has cleanly solved before and build the structure that solves it, then know exactly when to trust the machine and when to override it. The programmers who quietly worried they'd become obsolete were often measuring themselves against the wrong skill the entire time. The ones who built their careers on genuine decomposition, on architecture, on the deep pattern library that catches confident wrongness before it ships, are discovering something nobody predicted a few years ago. The tool that was supposed to replace them, turned out to need them more than ever, just to know when not to trust it. Do you think AI is making the skill gap in programming wider or smaller? Let me know in the comments. I'd love to read what you're seeing in your own work.